In this video, we're going to talk about hyperbolic functions, and let's compare it with trigonometric functions. Trigonometric functions are based on the unit circle. The formula for that is x squared plus y squared is equal to 1. That is the equation of a circle where the radius has a value of 1. That's why it's called a unit circle, since r is 1. Now, hyperbolic functions, they're based not on a unit circle, but on the hyperbola. One form of it looks like this. That particular form has this equation. X squared minus y squared is equal to 1. The only difference is we've exchanged a plus with a minus. Now, in trigonometry, you've seen this identity. This is known as the Pythagorean identity. It's cosine squared plus sine squared is equal to 1. Now, for hyperbolic functions, there's a similar identity. It's hyperbolic cosine squared of x minus hyperbolic sine squared of x is equal to 1. Notice the similarities. This equation corresponds to this equation here, the equation of a circle. This equation corresponds to the equation of a hyperbolic function. Now, hyperbolic functions are basically combinations of exponential functions. Hyperbolic sine is equal to e to the x minus e to the negative x divided by 2. So as you can see, it's just the combination of these two exponential functions. Now, hyperbolic cosine, it's very similar to hyperbolic sine. The only difference is we're going to change the minus sign to a plus. So it's e to the x plus e to the negative x divided by 2. So you may want to write these down because we'll be using these formulas a lot in certain practice problems. Now, hyperbolic tangent is equal to hyperbolic sine divided by hyperbolic cosine, much in the same way as the regular tangent function is sine over cosine. So if we were to take hyperbolic sine in its exponential form and divide it by hyperbolic cosine, we would get this. This is another form of hyperbolic tangent. E to the x minus e to the negative x over e to the x plus e to the negative x. Now, we could simplify that equation even further. If we multiply the top and the bottom by e to the x, notice what happens. First, I'm going to rewrite it. E to the negative x is 1 over e to the x. So this is what we have. And we're going to multiply the top and bottom by e to the x. E to the x times e to the x. When you multiply by common bases, you need to add the exponents. For instance, a squared times a to the third is a to the 2 plus 3, which is a to the 5. So e to the x times e to the x, you have x plus x, you get 2x. When we multiply these two, e to the x times 1 over e to the x, they cancel, and we're just going to get minus 1. Here, this is going to give us e to the 2x, and this is just going to give us plus 1. So hyperbolic sine not only equals hyperbolic tangent doesn't just equal hyperbolic sine over hyperbolic cosine. It equals e to the x minus e to the negative x over e to the x plus e to the negative x. And it also equals e to the 2x minus 1 over e to the 2x plus 1. So those are the different forms in which you could represent hyperbolic tangent. Now let's talk about the reciprocal functions. Hyperbolic cosecant is simply 1 over hyperbolic sine. Very similar to how cosecant is 1 over sine. Hyperbolic secant is 1 over cosine. And hyperbolic cotangent is 1 over hyperbolic tangent. So those are the basic formulas that you want to know when it comes to hyperbolic trig functions. Now let's talk about some of the graphs of the hyperbolic trig functions. So this is the graph of hyperbolic sine. We can represent it as y is equal to hyperbolic sine of x. The domain for this graph is all real numbers, and the range is all real numbers. Next, we have hyperbolic cosine. It looks like an upward parabola, and it starts at a y value of 1. So the domain is going to be all real numbers. X could be anything. If you analyze it from left to right, it goes from negative infinity to the left, positive infinity to the right. Now the range of hyperbolic cosine is limited. The lowest y value is 1, the highest y value is infinity. So it goes from 1 to infinity. Next we have hyperbolic tangent, which is bounded by 2 horizontal asymptotes. Y equals 1 and y equals negative 1. Hyperbolic tangent touches the origin at 0, and then it's going to follow each asymptote. So that's a rough sketch of hyperbolic tangent. And this is hyperbolic cosine. Now, the domain for hyperbolic tangent, if we look at the x values, the graph goes all the way to the left from negative infinity, and it goes all the way to the right to positive infinity. So the domain for all three of these functions is all real numbers. Now the range, it's bounded by the 2 horizontal asymptotes. So the lowest it could be is negative 1, and the highest it could be is 1. But it doesn't include those values. So we don't have a closed interval, we have an open interval. So it's negative 1 to 1. So that's basically it for this video. I wanted to give you just a basic introduction into hyperbolic trig functions. I'm going to have other videos on this topic, so feel free to take a look at that. So if you go to the YouTube search bar, type in hyperbolic trig functions, organic chemistry tutor, all the videos that I have on this topic should show up in the search results. So feel free to take a look at that when you get a chance. So if you go to my website, video-tutor.net, it's going to take you to this page where you can check out my ebook on how to pass math and science classes, or if you want to get the first chapter free, you can join my email list. So feel free to take a look at this when you get a chance, if you're interested. But now let's get back to the video.